Hey guys, so I know it's a snow day, but I know some of you are ambitious and some of you might be a little bit nervous about, a test that we have coming up this week. Will we have one? I'm not sure. Will LCPS cancel and have a snow day? Again, I'm not sure. But what I'm going to do is put a short little video together for you, kind of going over what we would be doing today in school. It's completely optional. If you want to check it out, you can. But if you want to look at some things that we would be doing to prepare for our test, we may still do it later in this week. But if you're find yourself bored or looking for something to do to stay sharp with the test coming up this week, then this is a great opportunity and a great video for you to check out. For the test this week, you're essentially going over graphing linear equations. On the first day, we talked about graphing using a table. We talked about graphing using x and y intercepts. Of those two things, only graphing x and y intercepts will actually be on your test. We're not going to have to worry about graphing using a table. Here's a video going over that concept, and of course the notes, some extra practice if you forgot how to do that. The next class we went over slope, rate of change. Again, here's a video that I made in the past, specifically going over slope, rate of change with some word problems. If you forgot how to do those, the notes and completed notes from this year and some extra practice. Then we spent a little bit of time doing a little more slope and rate of change and Hoy-Buck, so horizontal and vertical lines. All that stuff will be on your test. I think there's one question on a Hoy and one question on a Bucks, some extra practice. And then last class, we talked about slope-intercept form, which is y equals mx plus b, which is a very efficient way to graph your lines without having to use a table. You find the y-intercept, plot it, then you find the slope, plot that. Today we would be reviewing, so I'm going to go over a little bit of a review, and then you're hypothetically would be testing on later this week. We may do something asynchronously where I'll give you the opportunity, you don't have to test, but I don't know what our status is going to be for the actual test. Here's a warm-up. If you'd like to pause this video right now and try this question, you could then unpause it and see if you got the same answer. I'll read it for you. It says the table below shows the rate of zombie growth over the past 4 months. Obviously, I made this question up. Find the rate of change between months 2 and 4. So if you want to pause, now is a good time to pause. If you didn't pause, or if you want to see the answer, there is information in this table that you don't need. So this is an example, and you will see one like this in the test, where it's asking for months 2 and 4. So we're going to ignore months 1 and 3. The other key is to notice that it says rate of change, which is another way of saying the slope. As you remember, slope is change in y over change in x. It's y2 minus y1. Remember with slope, y is on top, y is on top, y is on top, and you need to subtract. Obviously with slope, we need 4 numbers, and since we've eliminated some of the information, we now have 4 numbers. Now we have to decide which are my y's and which are my x's. Are these my x's and these my y's, or vice versa? As a general rule, well, it won't really matter, truly, if you're able to explain it, but as a general rule with word problems, we need to figure out which is the independent variable and which is the dependent variable. As you remember, x is your independent variable, y is your dependent variable. And the other thing we talked about is that x is time is almost always our independent variable because time just tends to go. It's not always. In this case, it is. X is our month, and zombies is our y. So we'll subtract in either order, but I'm going to make the bigger number first, 77 minus 29. Those are my y's. And then it's 4 minus 2 in the denominator, which is 48 over 2, which does simplify to 24 over 1. Now that would be the correct answer, but one thing that you need to be on your toes with when it comes to word problems is labeling your answer. So it's not just 24 over 1. The answer is 24 zombies per month would be the fully labeled correct answer. Could you say 24 over 1? You could. Could you do decimals if it were a decimal answer? Again, you could, since it's talking about a general rate of change. A follow-up sort of warm-up question, a trend that I saw on the quiz, which we'll go over shortly. Here's an example where a student, let's call him Mark, was told to determine the slope of the line shown down below. Not technically a line segment, but let's not nitpick for this word problem, this example. He said that the slope, it looks like, is 1/5. Is he correct? Well, let's count. Remember, slope is rise over run. And of course, at any point, if you want to pause to do the work yourself, you can. So how much is the rise? Well, in this case, the rise is actually a fall. It's going down. It's going down 1. And then it goes to the right. Looks like 1, 2, 3, 4, 5. So 1 over 5 on the surface would look correct, but it's actually not correct because, as you can see, this general line is a general slope of a negative slope, which would be validated by the fact that it didn't rise 1 as much as it fell 1. So the slope is actually negative 1/5. If you were asked to graph that, make sure, like, let's say you were asked to graph y equals negative 2/3 x plus 1. Firstly, you should check this in Desmos to see what it looks like. But secondly, if you graph this, you got your y-intercept of 1, and then you made your slope and it looked like that, and you made your line, which you'd want to do more points than that, but if you saw your line and you saw that it was a general positive slope, then you'd know it's wrong because the slope in this case is negative 2/3. If you were in charge of doing this, your slope, remember, is not the variable, it's just the coefficient, negative 2/3. And your y-intercept is, don't just put 1, write it as a coordinate with parentheses, 0, 1. So 0 up 1, and my slope is now down 2 over 3, down 2 over 3. I want to fill the page as much as I can. It doesn't take that long. Make sure you don't do a line segment. Make sure you do a line with arrows. Today, our objectives were to do the warm-up, to go over the quiz, and see who got the most shout-outs. The next time we're in class, we'll do that. I'm going to provide you guys the extra help link, which should be Thursday. However, it depends on what LCPS does. You may be looking at this on a Thursday. Then I'll give you links to this individual challenge, see who could do it. This Kahoot that actually Owen made, we'll have to hold off on that and maybe do that in class together because it's not as fun if you're doing it individually. And then your objective was to do the Desmos lab. We talked about, will there be a test? I'm not sure yet, but we may give you a chance to do it asynchronously if that is something that is, you guys would like to take advantage of. Here's the quiz from the last class. If you want to go back and look at your specific feedback, you can. Remember, I could see who saw and who didn't based on what color the triangle is in the top right corner. I anonymized the names, so you can't actually tell who's who. But let's quickly go through the 2 quiz questions, which were slides 2 and 3, to determine some of the mistakes that we made. So just looking at slide 2, it says to identify the slope as a fraction and the y-intercept as a coordinate. The slope, as many of you identified, it is negative 1/3. Nobody put the x, but I want to reiterate. If you write that the slope, if you say, oh, the slope, it asks for that, and you put negative 1/3 x, it's going to be marked as incorrect because the x is not part of the slope, just the coefficient, in this case, negative 1/3. Generally looking, most of you got negative 1/3, and you went down. Your slope is going down. Every once in a while, as Isaac Newton showed, some people drew a positive slope. It's not a positive slope. And you should know because you should be able to go to your Desmos calculator and you could graph it and you could verify y equals negative 1/3 x plus 1, I believe it was. 4, excuse me. And you could see that your graph goes down. So based on that, if your graph doesn't go down, it's not accurate. Now, also, you guys had arrows, which is terrific. The y-intercept, many of you fixed it. At first, you might not have had it. The y-intercept in this case is not just 4. Make sure you write it as a coordinate, 0, 4, down 1 over 3, and then use Desmos to verify. On the second question, the third slide, it asks you to identify the slope and the y-intercept. But if you notice, this is not written in what's called slope-intercept form. It did give you a hint and tell you need to write it in slope-intercept form. The first thing we need to do is solve for y. So this goes back to the topic of solving literal equations. which we told you will come back at some point. There are three terms. We need to isolate the term that contains my variable, which is y, because slope-intercept form means y equals mx plus b. We subtract 3x, subtract 3x. Bring down the negative 2y equals negative 3x plus 10. Send the constant to the end. Every term gets divided by negative 2. We have y equals, a negative over a negative is, of course, a positive. And 10 divided by negative 2 is negative 5. Many of you, if you made a mistake, you made a sign error. You either forgot that this was negative, or you added 3x, even though the 3x is positive, so we have to subtract it, or you just, generally weren't paying attention when you did this. So what should it have looked like? The slope, as let's say Isaac Newton correctly saw, it was 3 over 2. Unfortunately for Isaac Newton, he wrote his, or she wrote his or her y-intercept as 5 when it's in fact negative 5. It's a small little sign error, and either way, it should be written as a coordinate. So who did this correctly? Looked like Leibniz did it correctly. Annie Easley might have done it correctly. There are probably others down below. But your slope should have been 3 over 2, and your y-intercept should have been 0, negative 5. Again, you could verify this by graphing this in the Desmos calculator. The nice thing about checking in the Desmos calculator is you don't have to solve in order for it to check. Equals 10. And you'll see the y-intercept is clearly 0 and negative 5, and the slope, if you want to count, is up 1, 2, 3 over 1, 2. So you can see the slope is up 3 over 2. All right, so you might be asking yourself, that's all wonderful, but what can I do now? Well, you could study. When are we going to take the test? Are we going to take it on Friday? Are we going to start on Friday? Are we going to do it fully asynchronously? I'm not sure, but you can prepare for any scenario by just staying sharp and studying. So here are some things that you might want to do, and I'll provide links. The first thing you might want to do is sign up for Extra Help. Now, right now it says Thursday. I'm not sure if it'll be Thursday. Again, you may be watching this on a Thursday, but if you sign up for this, that means I know that you're interested in Extra Help, and I will provide you information on when it might be if we need to reschedule to Friday or Monday or Tuesday, depending on what the weather dictates. The other things you could do is this kind of bonus activity, which is slope intercept stars, just fun activity. We may do it in class where we may have you race. We raced in block 1. Essentially, you are going to click the launch button. The purple balls are going to drop, and your goal is to make it hit the stars. As you can see on this one, there's not really a whole bunch that you need to do. It will just drop using gravity in this case. On the second one, someone drew a line, and now this line is going to affect and essentially make a ramp for the balls to roll and then hit those stars, which otherwise they would have missed. On slide 3, you need to create that line, because if you just drop the balls from here, they're going to miss. So take a little time, experiment, get some practice with slope intercept form. The other thing you could do is the review day activity. There is no quiz, but one thing that might be interesting to you is that the answers are at the end of this activity again. So if you go through them all and you say you want a question on slope or graphing or Hoyes or Vuxes, here are some opportunities for practice, and here are the answers. Of course, the last thing, and for me, the biggest suggestion to do would be to do the practice test, which is linked at the top. The answers are also here. If you have any questions, you could email. You could do some Alex, if you're trying to stay sharp. Well, if you're still here, I'm going to show you just a couple of questions on the test. Obviously not the numbers, so you have a general idea of what's going to be expected of you. The first question is asking you to determine the slope of the line. So they'll give you 2 coordinates, find the slope. Over here, again, 2 coordinates, find the slope. The next question, same idea. It's going to give you 2 values. Find the slope, find the slope. It says write your answer in simplest form, which of course would mean that you need to write your answer as a fraction and not as a decimal. Here's one where it says determine the slope. So you're going to have to look at the graph. Another one where you'll need to look at the graph. Here's a word problem. This word problem is asking you to find the rate of change, also known as the slope. I give you 4 numbers. I didn't give you all 4, but make sure you label. Show your work, label. Here's another word problem. This word problem gives you a picture. This time, again, make sure you label. I covered up some of the information so you can't see the graph. And one more rate of change word problem, which again is asking you, very similar to the warm-up, to find the rate of change between just some of the numbers that we need. There are numbers down here which I blocked. There is a second section of this test. It's on linear equations, so graphing lines, using the methods that we learn. The 3 real main topics that we're hitting is x and y intercepts, slope-intercept form, and Hooy-Vox. The first question is asking you to determine the slope and y-intercept for each. So look at this one, determine the slope, determine the y-intercept. Do the same thing for that one, and the same thing for that one. You may have to write it in function form first. Make sure your slope is in fraction form, not a decimal. This next question is asking you to take the equation, which I'm hiding, solve to determine the x-intercept, solve to determine the y-intercept. As you remember, the x-intercept means y is 0. You plug in, get your coordinate, ordered pair. Y-intercept is x is 0, so start over, plug in 0 for x, solve for y, write that as a coordinate, and when you're done, you should have a line. My suggestion would be to take this equation, graph it in Desmos so you can see what the answer would look like, so you know if you did it correctly. Arrows on the ends, etc., etc. I'm stressing again, make sure these are each coordinates. You should end up with a line, not one dot on your coordinate grid. Slide 13 is asking you to take this equation, again identify the slope and the y-intercept, just like a prior question, and then graph it in its entirety, starting with the y-intercept, and then doing your slope, rise over run, or if it's negative, fall and then run, fall and then run. Check it in Desmos. Slide 14 is very similar, but you may have to solve for y first, put it into what's called function form. And the last question, one on each, a Hooy and a Vox. I'm not saying which one's which, but you should end up with a horizontal line and a vertical line. These ones should be toss-up home run gimmies, especially because you can graph them in Desmos and see what it should look like. Make sure you put arrows on the ends. Well, if you made it this far, hope you enjoyed seeing the test. Hope that was beneficial for you. Stay in touch. Email me with any questions, and we will do at least some sort of review before you take your test, even if it's short, right? The class that will take the test, or maybe an asynchronous test. It's entirely up to you, whatever you're most comfortable with, whether you want to take it before the long break or after the long break, or, we'll see what happens. Either way, hope you enjoy your day, and I hope to see many of you soon.